So if the copper carbonate is reacting with the acid and the powder completely disappears, what that means is that the acid is in excess. So there's more acid than you actually need in order to make it to react. Okay, during reaction, pH changes and it goes from 2 to 6. I'm going to take it in stages. So each pH number is there. Now remember, when pH changes by 1, so if I go from 2 to 3, the hydrogen ion concentration changes by a factor of 10. And because this is becoming less acidic, then it's the same as dividing by 10 each time. So every time we go pH of 1, we are going to divide by 10. So we've got 10 times 10 times 10 times 10, which is 10,000. But because we are dividing by 10, it is 1 over 10,000. So the only option that matches that is option D. Okay, next one. We have done a reaction where we are producing copper sulfate solution. What should be done to get the crystals from the copper sulfate? So what we have to do here, this, because it's a solution, that means this is soluble. So what we're going to do is heat the mixture, and that will evaporate the water from the mixture, from the solution, sorry, to get 1 mark. And then we leave the salt to dry, often in between pieces of filter paper, and that absorbs any remaining moisture. Okay, next one. So chloride ions are added to this pale blue solution, and you can see the equation is reversible because it's got this symbol in the middle. So this means Le Chatelier's principle applies to these calculations. So what we're going to do here is, what effect does removal of chloride ions have? So what I'm trying to do here is take those ions out of the reaction. If you remember Le Chatelier, it says it does the opposite. So a reaction at equilibrium will do the opposite to the change imposed. And it's, if we are trying to remove those ions, the reaction is going to try and replace them. And it will do that by moving towards the left. And if it moves towards the left, we're going to get more of this pale blue solution forming, meaning that the solution will start to turn blue, is the right answer. Okay, the last one is a calculation. I'm just going to go through the working out with you step by step. What I always suggest you do is, in the equation, we write down the numbers that we are given from the question. So we can see here, it says the mass of water was 4.5, so we've got 4.5 underneath water. Calculate the mass of hydrated, this is the hydrated copper sulfate that had been heated. So I'm trying to find the mass of this, and we're given some masses to help us do this question. So the first thing to do is take this mass, and we need to convert the mass into moles. So to work out moles, we do mass divided by mR. So you can see here we've got moles of water is the mass divided by the mR. The mass is 4.5. The mR for water is 18, because you've got oxygen is 16 and 2 hydrogens is 18 in total. Work that out and we get 0.25 moles. 1 mark if you got that far. We then go back up to the question and we look at the ratio from the question. So we have got 5 moles of this and 1 mole of this are reacting. So I've written that down here. We've just worked out that we've got 0.25 of this. So I'm trying to get from here to here, which means we are dividing by 5. So if I divide that by 5, I get an answer of 0.05. If you get that answer, you get yourself another mark here. Then the final little bit, we need to calculate the mass of this many moles. So we're working out the mass. So mass is mR times moles. So we want the mass of this hydrated copper sulfate. mR times moles. The mR is 249.5. times it by the moles, and we get an answer of 12.48. I'm just checking, does it ask me to give the answer to any significant figures? I don't think it does. I've just written it as 12.5 there, and there's the extra mark in your answer.